Okay, so in this example, we are given an initial value problem with differential equations, and we want to solve it. So we will start with the characteristic equation, solving the determinant of a minus lambda I being equal to 0. And doing that, we have 4 minus lambda to negative 40, negative 12 minus lambda, the determinant of all that being equal to 0. And doing that, we have 4 minus lambda times negative 12 minus lambda plus 80 being equal to 0. Multiplying all this stuff out, we get negative 48 plus 8 lambda plus lambda squared plus 80 being equal to 0. That gives us lambda squared plus 8 lambda plus 32 being equal to 0. Then over here on the side, we'll do some scratch work of the quadratic equation. So negative b, so negative 8 plus or minus the square root of b squared, which is 64, minus 4 times a times c, which is 32, all divided by 2. When you simplify that, you end up with negative 8 plus or minus the square root of negative 64 all over 2, which, again, simplifying more, you get negative 4 plus or minus 4i. So that's great because that gives us our eigenvalues. Lambda 1 being equal to negative 4 plus 4i. Lambda 2 being equal to negative 4 minus 4i. And we will look at this. In this case, because we have complex roots for our eigenvalue, we only actually need to look at one. And in this case, I don't know, I'm thinking this looks like the easiest one. So that is where we start to find our eigenvectors. And that is found from a minus lambda I times some k being equal to 0. So let us do that. Our lambda sub 1 is going to be, we chose negative 4 plus 4i, or I chose it. And writing that out, we get 4 minus lambda, which is negative 4 plus 4i, to negative 40, and then negative 12 minus negative 4 plus 4i, times k sub 1, k sub 2, being equal to 0. Alright, and then simplifying that a little bit, cleaning that up, and I'm going to just write it in matrix form. We end up with 8 minus 4i to 0, negative 40, negative 8 minus 4i, and 0. And then we want to do some matrix arithmetic or manipulation to try to get the matrix in row echelon form. So what I'm going to do is multiply the first row by 40, and then add 8 minus 4 I times row 2, and then leave the result in row 2. So doing that enables us to simplify one of the rows, as you see. So we leave the first row alone, essentially, so it's going to be 8 minus 4i to 0. That's not going to change. It's the second row that everything gets adjusted in, and that ends up being 0. The second row, second column is going to be 80 minus 8 plus 4i times 8 minus 4i. When you factored out a negative from there, so that just made it nicer, which does create a conjugate, so the i's are going to cancel out there. And simplifying that part, we end up with still 8 minus 4i, 2, 0, 0. This ends up being 80 minus 64 plus 16. And you can kind of see what happens there. The first row is still just 8 minus 4i, 2, and 0. But the second row is just a bunch of zeros, which is nice because it simplifies things. Next, we can write it in its component form. So I'm going to write it as 8 minus 4i times k sub 1 plus 2k sub 2 being equal to 0. And then that also, because we can see the second row is a bunch of zeros, we have a free variable for k sub 2, so we could just say k sub 2 is going to be k sub 2, whatever it wants. And to make things a little nicer, I'm actually going to multiply this whole equation here on the top by its conjugate, 8 plus 4i. That just will help right here, making that a real number. So doing that, we have 80 k sub 1 when you simplify it and multiply it out, plus 2 times 8 plus 4i, k sub 2, then that equals 0. And again, k sub 2 is just itself, k sub 2. And now we can solve for k sub 1. K sub 1, when you do this, you end up with, and I'm just going to write it, negative 140th times 8 plus 4i times k sub 2. And then k sub 2 is just itself. And what's nice about that is that just means k sub 1, k sub 2 will be equal to, if we choose a nice number like choose k sub 2 being equal to negative 40, that gives us a nice eigenvector, and that eigenvector just ends up being 8 plus 4i, negative 40. And that is our eigenvector, and we can essentially write one of our solutions as x1 of t being equal to e to the lambda, and the lambda is negative 4 plus 4i, so negative 4 plus 4i t times that vector, which is 8 plus 4i negative 40. And simplifying that even more, we can split this up as e to the negative 4t times e to the 4i t, and then times is 8 plus 4i negative 40. Then if you notice, I have written kind of what e to the I theta can be written as in terms of cosine and sine. So we're going to do that. And when we do that, let me box this first so it's kind of out of our way, or my way. When we rewrite it in terms of cosine and sine, we get that equals e to the negative 4t times cosine 4 theta, not theta, I want t, plus I times sine of 4t times this vector 8 plus 4i negative 40. Right? So from there, notice I wrote this general solution. What we are essentially trying to do is find our vector here and vector here, which I labeled as u of t and v of t. So ultimately we're going to try to manipulate this to look like this. So just continuing that process, what we can do is distribute all this to this stuff and maybe simplify. So I'm going to do that. So again, I'm going to just put x of 1 of t being equal to, when we do that, we can take out the e to the negative 4t, leave it on the outside, and when we distribute everything, all the cosines and the sines, right, we'll distribute it to this and this. So doing that, we get 8 cos 4t plus 4i cos 4t plus 8i sine 4t plus, when you multiply 4i times I sine 4t, you get an I squared term, and that I squared term is equal to negative 1, so we can change that to, I'll erase that plus mark, minus 4 sine 4t. And then the bottom row, the second row, distributing the negative 40 to each of the cosine and sine, we get negative 40 cosine of 4t minus 40i sine 4t. And what's cool about this is notice we can split the real terms with the imaginary terms, right? There's the imaginary terms and there's the real terms. We can split that up, and what we end up with when we do that is e to the negative 4t times 8 cos 4t minus 4 sine t of 4t. And then we have minus 4 cosine of 4t. Nope, not 4. Shoot. Negative 40. And that is added to I times e to the negative 4t with a negative 4 cosine 4t plus 8 sine 4t, and that's a negative 40 sine 4t on the bottom. And what's wonderful about this is we can see that it fits this form here, kind of. Well, we have two kind of independent solutions right here, which I will label this as a u vector t and v vector t. And we can then write that out as our general solution is going to be equal to some constant times the u of t, which is e to the negative 4t, 8 cosine 4 of t minus 4 sine 4 of t, negative 40 cosine 4 of t in the bottom, plus constant times e to the negative 4t, negative 4 cosine 4t plus 8 sine of 4t, negative 40 sine 4t. And, phew, this is a long problem, right? We also were given initial values, and our initial values, I'll remind us, was y of 0 being equal to negative 628. So, well, actually, what I should do, because I'm switching notations here, should call that x of 0 instead of y sub 0, since that's how I wrote it. So x of 0 equals negative 628, which means we have a system where we have negative 628 being equal to c sub 1. We have e to the 0, that just makes it 1. And then we have cosine of 0, which is 1, so we'll have 8 minus sine of 0, it's just going to be 0. And then on the bottom, negative 40 cosine of 0, which is just 1. So we'll have that, c1 times c1, plus c2. Again, e to the 0 is 1, so we will just be left with what's stuff on the inside. We'll have negative 4 plus 0, since sine of 0 is 0. And then on the bottom will also just be 0. And that's nice, because now we will just have, I'm going to write it down here, negative 6 being equal to 8c1 minus 4c2, and 28 will be equal to negative 40c1. And that's nice, because then c1 is just equal to negative 28 over 40, which does simplify to negative 7/10. And that gives us a way to find c sub 2, which when we plug it in and simplify and solve for c2, we get negative 1/10. So, kind of going back up there, we now know we have our solution with the initial values given. It's going to be equal to c1 so negative 7/10 times e to the negative 4t times 8 cosine of 4t minus 4 sine of 4t negative 40 cosine 4t plus c2, which is negative 1/10 e to the negative 4t times negative 4 cosine 4 of t plus 8 sine of 4t negative 40 sine 4t on the bottom there. And whew, this is a long one for sure. When you simplify all this stuff out, what you end up with is e to the negative 4t, make that nicer, e to the negative 4t times negative 6 cosine of 4t plus 2 sine of 4t, 28 cosine of 4t plus 4 sine of 4t. And you can leave it as is, or if you want to separate it, which I believe the homework system does, we can say x of t will be equal to e to the negative 4t, and I'm just going to leave that on the outside. Negative 6 cosine of 4t plus 2 sine of 4t. And then y of t will be e to the negative 4t times 28 cosine of 4t plus 4 sine of 4t. And that is the solution to our initial value problem for the system listed right here.